Hi, everyone. Good morning. It's Mr. Vallejo, and welcome to Science Labs. Today at the VRC Science Lab, two things that we'll do. Two things. First thing is I'm going to be setting up a marine biology lab. And who likes marine biology here? Anyone? Yes, all the people raising their hands. Yeah, marine biology. And in marine biology, not only do we study whales and sharks and fish and things, but we also study small critters. So that's what I'm looking at, something called invertebrate biology or even invertebrate zoology. And as we study animals without a backbone, one group is called the mollusca. And the mollusca are the soft-bodied animals. Um, I have some shells here that I want to take a look at with you. And these shells are uh, obviously not soft, but they're very hard. But inside the shell, you have that soft-bodied animal. And so that's why all animals in this group, the mollusca, have soft bodies. This includes the gastropods, which are the snails and the slugs. They have soft bodies. Snail has a shell though, but it has one shell. We have in another group, we have the bivalves, which are a type of mollusca. That's what clams are. Clams have two shells, but they do have a soft body in there. And then the third thing is that uh, you have the squid and the octopi. Those guys are soft-bodied, but then they don't have a shell, or at least one that's not obvious to you. The squid has an internal shell. If you've ever uh, prepared calamari or some type of squid dish, when you're taking apart the animal and getting it ready to eat, you can pull out a it's not plastic, but it looks like a piece of plastic. It's transparent and it's kind of hard, like a like a 2 liter bottle, like that. And and that is the internal skeleton of the squid. Okay, so today we're looking at bivalves, which are a type of mollusk. And my question today is, how can you determine the age of a clam? I have a worksheet here, and I'll read you the introductory paragraph. It says this: most mollusks, such as clams and mussels, have hard protective shells. Clams grow in size each year. However, they do not shed their old shells and grow new ones instead. New layers are added to the shell as the clam grows. Like clam, many other mollusks increase in size by adding a new layer to their shells each year. So I'm going to go to my document camera like we often do, so you can see some of the things I'm working with. And let's see. All right, so there's my screen. I have some shells that I'm working with right here. Okay. Here you go. It's a little too bright here. So let me fix the camera to give us a good look at those. Still a little funny looking. So yeah, that's too bright. We need to be able to see those bands, because what it is, you guys, is it's like the rings on a tree, right? So what we're going to do is we're going to count those, and then we're going to figure out the average bandwidth is, the number of bands, and then the age of the shell. Okay, so let me get rid of these for a second, and we'll set up a data table and record our information. It could be something like this. Let's call it clamshell bands. Let me focus that. Okay, we're going to have 4 of them all together. But what I need to do is and I'll just write shell, and we'll call it, I have 4, so we'll call it A, B, C, D. So like that, there's A, there's B, C, and D. All right. First thing I want to do is I want to figure out what the average bandwidth is. Now remember the average, and because you guys have some math background, but who can tell me how to calculate an average? Anyone know? Zach, how do we calculate an average?
You add all of the numbers and then divide by the amount, or not by the by how many numbers there were.
Right, that's exactly right, Zach. So what you got to do is you got to add up all the numbers and divide by the number of incidences or the number of things that you have, or in this case, I'm going to take a look at the number of bands, and I'm going to divide that sum, which is the total, when you add it all up, and then that's how I'm going to get my average bandwidth. Okay, I'm also going to count the number of bands. So there's a number sign, number of bands. And I put that over here like this. And then we'll say age of the clam. It'd be like that. All right. So that's what my data table looks like. Let's take a look at our first one. To make it easier to see, on some of them I have a little pencil line, and that'll help me to figure out how many bands I have. Some of them are harder to see. The distinct, uh, the the actual band. Sometimes you have to turn it on the side to see it, because this one looks like it has hundreds of bands. But if you look at it from the side, you see that some of them bump up more than others. So from here to here is a band, right? And then from there to there, when you feel the next ridge, that's a band. So this one has a lot of bands all together. Let's take a look at this one, and you can see well, what I wanted to do is measure the width. So I'm going to measure the width of these bands with my ruler. And so I've got a ruler here that has inches on it. So I'm going to get a different ruler. That more easily has the millimeters on it, because you can see they're right there, but it's kind of hard to see for me. So I'm going to go and take a look at this one right here, and we'll take a look at the first band, which is right there, and that one is, well, that one's about 3 millimeters. So I'm going to write 3 right there. My second band goes from there to about there. And also looks like it's at 3. So that one's 3, 3. If you eyeball it, it looks like they're all about 3. This one's closer to 4. That's a bigger one. Right, the 1, 2, 3 right there. Here's another one. Maybe also, wow, maybe that one's even 5. We take a look at it. So I got 5 and a 4 and a 3. So plus 5 plus 4 plus 3. Okay, so I got, this one's our 3, this is 3, this is 4. Oh, sorry, I can't see. 4, 5. This one right here is 4. This one is 3. We're going to count a couple more there. That one looks like it's 4 to me. And then this one looks like it's 3. So I'm going to put them in reverse order because I was going up here, up until there. So if I add these up, that's 10 and 15. That's 19, 22, 25. It's 29. Okay, and I have 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8. And I have 8 bands that we counted. Let's make sure. We have 1, 2, 3, 4, 5, 6, 7, 8 that I counted. So now I'm going to take the average. I'm going to go like this and turn on the calculator. And there it is right there. All right. So 29 divided by 8 equals 3.625. 3.625. So that's the average bandwidth for 8 bands. But if I keep looking at this same one, 1, 2, 3, 4, wait, 1, 2, 3, 4, 5, 6, 7, 8. You can see there's more bands here. There's a 9th one. Up here it's 10, 11, 12, 13. Then after that, we're going to say that 13 and this whole thing here is the first year. So that's 14. So the total number of bands is 14. So if it's like a tree ring, if it has 14 bands, how old do you think it is? Anyone know? You can tell me in chat if you want. All right. So if it has 14 bands altogether, yes, you got lots of people saying 14. So thank you. Yeah. All right. So 14. And then you have 14 right there. Okay. So so that's how we do it with this lab. So that's the first one. I look for another one that isn't a slipper shell and has some obvious bands, because some of them are not so obvious. Let's see. Some of them are hard to count because they are because it's a different species of shell. So there's the one. What else we got here? I have a whole set, whole class set. This one's called umbo. No, actually, what is it? Well, it's part of the shell is the umbo. All these are very similar. So let's just take a look at another one. Here's another one right here. And we're going to call that shell A. And we'll call this shell B. This one's a little more difficult. And I should have got some glasses because it's hard to see. And you can see there through the magnifying glass. Not that easy, but you can see that this is a band right here from here to here. That's one. Right. That's 1, 2, 3, 4, 5. Then it goes over to here, 6. And 7, 8. Again, it's easier. You can see them live, and even on the edges, if you can fall to the edge, that's 9, 10, right there. And these bands are smaller. 11. And the next one actually is pretty wide. Goes to there, 12. Now let me refocus. 13 is this one here. 14, 15, and 16. So a clam that's this big, would you have guessed that it has 16 bands on it? Now it has a lot of lines, but if you were to hold this and feel it, there are lines that are more distinct than others. And over here on the side, they have some more prominent cracks. So those are the ones I counted. So 16. And how old is this if it has 16 bands? You're right, 16. All right, so you got 16 bands, you got 16 years because each year is a band. It's like a tree ring. So if we take a look at this, let me get the ruler back out. And these bands actually look smaller. You have a 3 centimeter one right there. Okay, and then continuing on out, I've got 3, and that one's 3 also. That one's also 3. All right, that one is 5. 3, 3, 3, 5. Now we have some smaller ones. 3, 3, 5, 2, and 3, 3, 5, 2, 3. 3, 3, 5, 2, 3. This time I'm going to add those up. I have 11, 12, 13, 16. 16 divided by 5 of them I counted this time. So when I get the calculator out, I got 16 divided by 5, and that's 3.2. So these bands are a little bit smaller, which makes sense. This is older. It's got a few more bands, and those bands are a little bit smaller, and these are about the same size. Okay, so that's how we do that. Now we've got our first two. Let's do a few more. Here we go, 1, 2, and then this band right here is this really big one. 3. Let's see. Hard to see on this now. I mean, because if you take a look, you feel it. You can. Well, I can feel it, but if you can see it, it looks like each of these is a band. But if you see it on the edge, see if it'll focus on that. 1, 2, 3, 4, 5, 6. And this whole other thing is 7. So this one only has 7, and it is smaller. But we can use those cracks on the side to help us figure out which ones are bands and which ones are not. So let me see if I can, let me get a pencil. And mark that a little better. That the pen mark doesn't pick up. So there's one. And again, I can see it on the sides easier. So where there's a good sized crack, that's a band. Not all of them are annual bands. I mean, obviously they're bands, but they're not all annual bands. And this one I actually put right in the middle in between 2 bands. So oh wow, try to get rid of that one. Okay. So 1, 2, 3 right there. It comes over here, 4. right there. 5. This one comes over here like this. So I got 1, 2, 3, 4, 5, 6, and then 7. So let's take a look at the size of those right there. I can get all 6 of those other smaller bands. Let's see, we have so we can see the numbers. That is, well, let's use the other one. It's hard to see. Okay, definitely bigger. 5, 7, 8, 4, 5, 7, 8, 4. 1, 2, 3, 4. And then I got 2 other ones that are smaller. That looks like a 3. And that looks like a chip. So maybe depends where you are. 3 and maybe a 5. So let's look at that one. We have 24 plus 3 is 27. 27, 32 divided by 5. Hey Siri, 32 divided by 5.
32 divided by 5 is 6.4.
6.4. So these have bigger bands than the other ones. So 6.4 is the average. 7 bands though, 7 years. And just so we can finish this up, let's have one more. Here's an interesting looking one. I don't know if that's some kind of marking there. Looks a little like a rust, but these are all of these are from Orange County. So that's where all these were collected along Huntington Beach. There are some beaches in Central California that have larger clams, like the Pismo clam found in Pismo Beach. And I'm marking these, and you can feel them. And like I said before, you can see them on the edges sometimes, but this one's not as good at that. Well, here, this edge, you can see the band right there, and it moves over. That's it. Here's the other one. Here's the next one. And the next one would be, if I follow that along. Oh, that doesn't seem like an obvious band to me, but that's where it is. So let's look at this. We've got 1, 2, 3, 4, 5, 6, 7, 8, and then this structure here is 9. So we're going to call that 9 bands, which makes it 9 years old, right? But let's take a look at the average of this fourth one. Okay. You got 7, 5, 4, then it gets smaller. 3, 4, 3, 4, 3, 4, 3, 4. And actually, I got one more at the end, which is you know what? That's inches. That's why it looks funny. So let's scratch those numbers. And it's 7, 6, 6, 6, 7666 6 3 6 3 4 4. So let's look at that again. That's 7 6 6 6 6 3 3 4. Okay, looks good. Adding those up, that 6 times 4 is 24, plus 3 is 27, plus 4 is 34, plus 8 is 42. Well, it's going to be 42 divided by 8. And 42 divided by 8 is what? 42 divided by 8 equals 5.25. So this one right here is letter D. Put a D on that. Okay. And then got our other ones here. That one, this one over here. So you can see some of the differences between all those shells right there. So cool. Here's the A. So there's your A and B, C, and beyond this. I should have done this at the beginning. So we'll make that shell A. And then what's this one? 1, 2, 3, 4, 5, 6, 7. And this one was 1, 2, 3, 4, 5, 6, 7. They're both 7. So, oh, this must have been the 16. Okay, so that's C, and this one here is B. This one's D. Okay, so now I've got my information, my data, and completed my data table with the average bandwidths. And the number of bands gives us the age of the clam. So that's pretty cool. Now you should be able to answer some questions on this. So obviously, if you take a look at it, the average width was not the same. Okay. And let's see, the bigger ones, there's letter A, and here's letter B. The bigger ones seem to be, not surprisingly, these guys had more bands, A and B did, than C and D. And so, let's see. Okay, so that's I don't know if you knew that already, that the age of a clam can be figured out by counting the rings. But that is a pretty cool feature. So let's show you your table in case you're writing that down. You have clamshell. A was 3.65. Our biggest one, I think, was B, and makes sense. It had a older. I mean, it's older, and it's the biggest shell that we did today. This one's pretty big, and it's only 7 years old. Right, that's letter C, and then this one here, letter D. Also, almost as big as this. Well, yeah, almost as big as C, but you can see that the bandwidth was a little bit smaller than C. Interesting that this guy had the largest bands compared to all these other three. And it's almost as big as the A and B, but it is definitely the youngest. So those are some things that we could see when we take a look at the clam shells. And so there you go. All right, so that is age of the clam, and that's how we can determine the age of a clam by counting its rings. All right,